Okay, Monday, May the 4th. May the 4th be with you. Okay, anyway. So we're starting reactions today. The first thing we need to do is we need to be able to look at a reaction, identify the type of reaction. Okay, I have a really good hands-on activity that I love to do with students for this, where I give you some cards. We start with some that just have numbers on them, and number reactions instead of formula reactions, and you kind of group them based on similarities and differences. So I'm going to try to model that for you. I have done the reactions, and so actually what I would like for you to do is let me give you directions, then I want you to pause me, and I want you to try to do this, and then I'm going to do this a little at a time, giving you other chances to pause me and try to figure out some of it on your own, okay? So what I want you to do is I want you to look at, there's 15 reactions, and look at the format of the reaction and see if you can find similarities and differences, how they're the same, how they're different. Why do these three go together and this one does not go with them? Okay, so pause me and see if you can group some of them together into groups. You should have 5 groups that each have 3 reactions. So go ahead and pause me. Okay, hopefully you paused me. Okay, so I'm going to move some of these around. So lots of times students will pull these two together. Okay, and they will pull them with this one. Okay, not that this is right, wrong, or indifferent, but just I want to show you things that students generally do. Okay, so they say this is 2 things on one side and 1 thing on the other side. Okay, and then they also will make this group. This one and this one and this one. And they say these are 3 things on one side and 1 thing on the other side. Okay, but if we think about it, and if we line up those equal signs, are they really the same reaction? Are they really doing the same thing? Okay, really they're not. This is 2 things combining to make 1 thing, and that's 1 thing that's breaking into 2 pieces. Okay, so then this is 3 things that make 1 thing. This is 1 thing that breaks into 3 pieces. So is it about how many things it is, or is it about whether there's 1 thing on the left of a reaction or 1 thing on the right of a reaction? The right answer is that the actual thing you see is that these are all things combining to make 1 thing. These are all 1 thing breaking into pieces. Okay? So, put these right here. So now you've got 9 more. So here's you another chance to pause me. Go ahead and pause me and see if you can figure out a way to group some of those. Hopefully you paused me. Okay, now there's 1 group of these that are pretty easy to pick out. Okay, if you see this one and this one, they both give you 44 and 18. And here's 1 more. It's 18 and 44, but that's I call it the additive property in math class. It's not really the additive property, it's really the commutative property, I think. But it means that as long as you're adding, you can add them in any order and you get the same answer. Okay, once we start doing multiplication and addition, then we have to worry about PEMDAS and all of that. But okay, so one more time, pause me, see if you can divide these into 2 groups. Hopefully you paused me. Hopefully you divided them. What? It's in the chair. um, at the table. Okay, and you can just pull 3 of them. Okay, and you look at them and you say, are these the same? And some people look at them and they say, well, this is a 5 and a 2, and then that's a 2 and a 5, so it's trading places. A 9 and an 8, a 9 and an 8. So the front number traded places on this one. This one is 2552, 7227, 7117, 4664. Well, that didn't get them separated. Okay, so then look at 3 of them together. Okay, and chances are you're not going to get 3 that go together when you pull them like that. And look at them and see why would one of them maybe not belong with the others. And you could look at these 3 up here, or you could look at these 3 down here. Okay, and think about what makes them need to be together and what might make them need to not belong. Okay, hopefully you see that these are double-digit numbers, and this is a double digit with a single digit. Okay, and so then down here, which one of these is not going to go? It's going to be that one. Okay, so you end up with double digit, single digit, double digit, single digit. Okay, so now I'm going to go to a new page where I have these same strips. Okay, but I'm going to pull 3 that go together and talk about them, and then I will go to another page to do the next. Okay, so let's look at that first group that we put together, which was A and F. I'm just going to move these others out of the way. And here it is, E. Okay, so let me move all these down. Okay, so these are things adding together to make one thing. Okay, so these are called synthesis reactions. Okay, they're going to have more reactants than products. Okay, can be 2 reactants or more. Okay, so what you're going to do today is I've got 20 reactions for you, and you're going to go through them and you're going to decide which type of reaction they are. And so what I might do is I might look at that. I might find all the ones I think are synthesis, mark them, and then look at your next type. Find all of them and mark them. And then look at the next type. Find all of them and mark them. Okay? So, synthesis reactions. More reactants than products. Okay? You could have 2 products and 3 reactants, or 4 reactants and 2 products, or 3 products. As long as there are more reactants than there are products, it's synthesis. Okay? The next type, if that's going to be, oh, I got to get my arrow. Okay, so that one, this one. So these are kind of the opposite of synthesis. Okay, and this is a word that, synthesis, you've probably heard that word, but it probably wouldn't be a word you would just pull out. This one is a more common word for you that you've used before. So these are called decomposition. Okay, and if you think about decomposition, what does that mean? It means breaking apart. Okay, these are the opposite of synthesis. And hopefully you are writing some stuff down as we go. These are going to have more products than reactants. Okay. Decomposition, let's make that bold. So you're breaking it apart. Opposite of synthesis, there's more products than reactants. Let me go back here and add opposite of decomposition. Okay. Now, next type all of those that equaled 44, let's get a thing, 44 and 18. So that one, this one, and this one. Okay, so this is a group that they all equal to 44 and 18. And so this is a special group because you always get the same two products. You always get the same two products. These are called combustion reactions. Okay. combustion, combustion reactions. Okay. Always get the same two products. And I'll tell you those products are CO, I don't think, oh, it will let me do subscript down here. CO2 and H2O. Okay. This is a hydrocarbon. Burning in the presence of oxygen. So these are probably the easiest ones to pick out because they are so characteristic. Okay, so like I said, this is probably the easiest one to pick out because you're always going to have that carbon dioxide and water as your two products. Okay, so we have two more groups. That first group, let's do, I keep forgetting to get my arrow whenever I come back over here. Okay, let's do this one, those double ones, and this one, and not that one, this one. Okay, and so these are called double replacement. Where's my, there it is. Okay, so these are double replacement. Occasionally you'll see this as displacement, double displacement, but it's the same thing. Okay, so this is going to be a compound plus a compound, and you get a compound plus a compound. Okay, so where we have a double-digit number, that's going to represent in a real reaction a compound. Okay, something that's bonded together. It's made of two or more elements. Okay, there's an E right there. Bold that. Bold. Okay. And so then our last group would be the ones with the single digit. So what do you think those are going to be called? Single replacement. Single replacement. So this is going to be an element plus a compound, and you're going to get an element plus a compound. Okay? Or it could be compound plus element and compound plus element, as long as it's a double digit, single digit, double digit, single digit. It could be single digit, double digit, single digit, double digit, as long as on each side there is a thing that's a single element and a thing that is a compound. Okay? So today's work, you're going to have, again, those 20 reactions. You're going to identify each of them. It's in a table, and so in that second column, you're just going to type in an S for synthesis, a D for decomposition, an SR or SD for single replacement, a DD or DR for double replacement, and a C for combustion. Okay, and so again, this can be replacement or displacement. Okay, tomorrow we're going to look at balancing equations. And then Wednesday, we're going to predict the products of synthesis and decomposition. If we're given the reactants, how do we find out what the products are supposed to be? And then Thursday, we'll predict single and double replacement reactions. And then Friday, you'll have a quiz on reactions. Remember, on Friday, we will have our WebEx. That is every single Friday at 11 o'clock. Okay? Talk to you soon.